So today we're going to talk about transformations of exponential functions and logarithmic functions. We learned how to graph exponential functions and logarithmic functions, but we never did actual transformations of those. However, we did learn about transformations of exponential functions in grade 11. So what we're going to do is for each function, we're going to sketch the graph of the parent function, and then we're going to take a look at some equations that do transformations to that parent function, and we're going to perform those transformations and graph them. So the first parent function that we're going to take a look at is y equals 3 to the exponent x. So we talked about three key pieces of information when we graphed exponential functions, and those three key features for our y equals 3 to the x function would be the 0 point, the 1 point, and does anyone remember what the third point is?
Yes.
What is it?
It's not 0 and 1.
Or maybe I should say the third piece of information. The 0 point, the 1 point, and what? No. The horizontal asymptote. Where's the horizontal asymptote for this function? Got to trust yourself, Simran. It's at y equals 0 for all basic exponential functions, and then it will shift with the vertical shift. Okay, so in order to get my y coordinates here, I'm going to take each of these x coordinates and we'll plug them in for the x in the function to get the y. So 3 to the exponent 0 is 1, and 3 to the exponent 1 is 3. These are the three key pieces of information that I'm going to use to perform transformations. If you feel like 2 points is not enough for you to kind of get a good feel of what the shape of that function is, you can always do 0, 1, 2, 3, or you can do -2 to +2, but make sure that you have the horizontal asymptote because that is kind of where your graph curves toward and doesn't cross, so we want to make sure that we pencil that in with the dotted line. So let's graph that one to start. I'm going to show the horizontal asymptote. Label it. And I'm just going to assume the scale is kind of going by ones here. So we'll graph the point 0, 1, and 1, 3, and I think this gives us kind of a good idea of what this function will look like. It's going to curve down toward the asymptote here, and then off to the right. And we'll label that graph. All right, now if you remember back to grade 11, you will see transformations of your exponential functions kind of in this format. So you're going to see an a and then some base to the exponent kx minus d plus c. And this is where the parent function is y equals b to the x. So the b is not a transformation. A, k, d, and c are transformations. But I'm going to see the a and c transformations kind of like on the outsides of the function. And then I'll see the x transformations, the k and d, they're going to be in the exponent with your x value. Okay, so k and d kind of always go in your function where the x is in your function. Okay, so can somebody identify A, K, D, C for me for part A? Fayak?
2 is A.
A is 2, good.
K is 3. Or 1 over 3, sorry. Or, no. There's no K.
So K is 1, right?
K is 1.
Sorry, Jonathan, I stole that one from you.
And then D is X minus 4.
So that's going to be your D value, right?
Yeah, D.
And
then C is minus 5.
Okay, so when I create my transformations here, I'm going to do x minus 4. We switch the sign of the D value. And then I'm going to do 2y minus 5. Jonathan, can you tell me why is k not equal to 3? What is the 3?
3 is the base of the function. K is in the exponent.
Right. So this is basically just telling me that my parent function is 3 to the x. It's not a transformation, okay? All right, so we're going to take our x's and subtract 4. We'll get negative 4 and negative 3. We'll take our y's, multiply by 2, subtract 5. Get negative 3 and 1. Any ideas where the horizontal asymptote will move to? Jonathan?
It's going to be the same as the C value?
Okay. So moves down 5, right? Okay, so we're going to draw it at negative 5. And then we're going to graph our 2 points here. So negative 4, negative 3, and negative 3, positive 1. Okay, so you guys need to make a call here, kind of the shape that your function will take. Really, the only options that I have are this. Okay, it could be that, or it could be this. What is the shape that my function is taking on here? Liam?
This one because it can't cross the asymptote.
Right, so I don't want to choose this because I'm crossing the asymptote here. So that shape doesn't really make sense with the points that I have. I want to curve toward the asymptote, like so, and then we'll curve up toward the right. Okay, and again, if you feel like you need more points than these two, just do like negative 2 to positive 2. You can enter those into your exponent to get your y coordinates, and then you'll have a few more points that you can use to transform. So I know some of you guys did that in our earlier exponential functions unit too. Okay, and then parent function for this guy is also y equals 3 to the x, so we're going to use the same 3 key features to transform here. Could someone identify a KDC for us in our second equation? Jonathan?
A equals 0 because there's nothing from the 3. K equals 1/2. There is no D value, and C equals 4.
I agree with K and C and D. What's the A
no.
value here? Liam? A value is negative 1, that's right. Okay, and if I don't see the A value, then the A value is 1, because that's like a multiple, right? If my A value were 0, then I don't have a function anymore, really. So, yeah, if we don't see A and K, they're 1. If I don't see D and C, those would be 0. So, can someone set up our equations for us here?
2x and negative 1 equals 4.
Perfect. Okay, so reciprocal of the K value, we don't have a D value, and then AY plus C. Okay, so we're going to get 0 and 2, and then 3 and 1. New location of the horizontal asymptote. Who can help us with that? Alexandra? Awesome. Okay, so let's pencil that in at 4 here. Okay, so we've got a couple options. I could have this shape, like so, or this shape. Yes, because we can't cross the asymptote, right? So we're going to curve toward the asymptote here and down toward the right. And then
It's
just,
already negative, so it has to be flipped.
right, so that would make sense, right? That we've kind of flipped the graph vertically. So you can think of it like that too. Any questions on these ones? Not too bad, just apply your transformations knowledge to these exponential functions here. Can I scroll? We're all good? Okay. So we're going to take a look at logarithmic functions now. So here our parent function is log base 3 of x. Claire and Fayek, you guys did something like this for your video. So if I know y equals 3 to the x is my parent function for the previous questions, and now we have y equals log base 3 of x, how are those two things connected? Well, I'm not saying like how do I get from one to the other, but what's the relationship between a logarithm and the exponential with the same base?
One's transformed and one's not.
Like one's just to go 3x, but one has a log. So one's log and one's not.
I think I might need to take some marks off of your assignment there. Jonathan?
Might be completely off. Isn't that basically another way of saying y equals root x?
Not really. These are inverse functions of one another, right? So a logarithm with the same base as its exponential counterpart, those two functions are inverses of one another, which means they are reflected over
The y-axis.
the line y equals x. Okay, so if I know the key points for y equals 3 to the x, we just talked about how those are, opposite. 0, 1, 1, 3, and a horizontal asymptote at y equals 0. The logarithmic function with the same base, how can I get the key pieces of information for that?
Again,
Jonathan?
brutally off, but is it 3 to power y equals x?
I don't need to switch the equation at all. I'm just talking about these three key pieces. How do they help us get the three?
Just log all of them.
No. Liam? We just swapped them. They're inverses of one another. And the horizontal asymptote becomes a vertical asymptote.
I was mine first. Just don't take marks off that.
Take marks off.
Changing now.
Take marks off.
All right, so you're going to see, for logarithmic functions, you'll see log of, or a times log of kx minus d, and then plus c. That's kind of where you'll see them. So again, the k and d are inside the logarithm with the x, and the a and c are on the outside. Okay, so in part A, what do we have out of a, k, d, c? No, we have some. Or sorry, and I should also say b, and this is where
You've got A and C.
y equals log base b to the x is the parent. So sorry, Jeremy, what do we have?
A and C.
We have an a and we have a c. You're right. So the x's don't change, but the y's will be multiplied by -4, and we'll add 2. Okay, so before we calculate our points, I just want to graph the parent function here, which are these three key pieces of information. So I'm going to pencil in the vertical asymptote here. And then we have 0, 1, and 1, 3. Or 3, 1, sorry. Okay, and logarithmic functions, they get kind of like mirrored over this diagonal line here. So they're going to come close to the vertical asymptote. And then the regular ones, they go off to the right. Once we do transformations, they might get flipped or whatever. But they can do that. Or if they are a decay, they'll do something like that. Okay, so our new function, sorry, let's just label that guy. All right, so our new function, the x's will stay the same. The y's we're going to multiply by -4 and add 2. Vertical asymptote, where does that move? Liam? So if I think about a vertical asymptote and I think about a vertical shift, if I shift a vertical asymptote up 2, does it move the location of the asymptote? So the d value will actually change this. So this one, because we have a d value of 0, the asymptote will actually stay at x equals 0. Okay, so we're going to graph those three key pieces. The x equals 0 is already graphed for us, so we'll leave that one. But we have 1, 2, and 3, negative 2. Any ideas what this function should look like? Yeah, coming from the top and kind of off to the side like this. Good. Okay, and that should make sense because we did a vertical flip, right? So now this function kind of gets flipped vertically. Okay, and then the last one, same parent function, so we're still dealing with log base 3 of x. And AKDC. Jonathan?
It's the same, what's it called? And then K is,
So this is in a bit of a strange format right now. We need to rearrange this just a little bit. Jonathan, do you have an idea?
take the, what's it called?
Negative.
The negative of.
Right, we need to common factor that negative in order to see the correct D value and K value here. So with the negative common factored, I think this looks more like it's in the format that we're looking for, right? With the K value common factored. So here is our K, here's our D, and here's our C. Can someone set up our equations for us? What's that? So it will, that's one of the transformations for x. There's also another one. Olivia? Minus 2. We have to switch the sign of the d value. And what about y? Liam? Y minus 4. Good. Okay, so we'll get negative 3 and negative 5, negative 4 and negative 3. New location of the vertical asymptote. Who can help us with that? Go ahead, Jonathan.
X is same to D values, so therefore it's 2.
Negative 2, actually. This is the shift left 2. Okay, so we're going to pencil in our vertical asymptote here at negative 2. And then you're going to graph your points here. Oops. Okay, so we have to curve toward the asymptote and around the asymptote here. So you should be curving down toward the asymptote here and then kind of going off this way. Okay, so just as a little summary for you guys, if you're dealing with an exponential function, you have really only 4 options for how your exponential function can look. And of course the asymptote can shift, so the shape would shift with the asymptote, but basically I can have something that looks like growth, decay, or the flipped versions of those things. So I can have this, or I can have this, right? But they all need to be curving toward wherever that horizontal asymptote is. So these are the 4 options for kind of the shapes that your graph can take for an exponential function. And then for logarithmic functions, or I guess I'll sit on that for a second for you guys if you want to copy it. Can I scroll? Tyson, you good? Okay. For logarithmic functions, you also only have 4 options, and they're kind of like very similar to the exponential ones, but with a horizontal asymptote. So, or with a vertical asymptote, I should say. So you can have this, you can have this, or the flips of those things. So you can have this or this. And of course, again, we know that that horizontal asymptote can shift. So you could have shifted versions of these to the left and to the right as well. Okay, just as a reminder, the key points that we dealt with for like 3 to the x and log base 3 of x, the summary is here for you guys. So everything basically that we just talked about, so where to find the a, k, d, and c, and the key points and the asymptote locations, and how they shift with transformations.